Hey everyone, today we're gonna be doing a late code question which is to find minimum and the maximum number of nodes between two critical points. So they are saying like a critical point in a linked list is defined as either a local minima or the local maxima. Okay, so if I say a local minima, or you can say local maxima here. Local maxima is a current node you can say, which is like strictly greater than the previous and the next node. Okay. Similarly, local minima is the current node which is strictly smaller than the previous and the next node. Similarly, they are saying that like note that the node can be either only the local minima or the maxima if it is having both the previous and the next node. So they are saying there should be exactly you can say at least three nodes surrounded by each other. Like if I say if some element is in middle, it should have a previous and the next node, which should be both minimum or both maximum. Then it can be called as local minima or the maxima. Okay, so they're saying in this question, like given a linked list head, you need to return an array of length 2, which contain the minimum distance and the maximum distance. So here distance means like, okay, what is the distance between two minimum or the maximum point? Whatever critical points we're gonna be getting here will be like represented as a minimum and the maximum point in the given array. So we will be doing that. Now, if you see here, like they are saying where minimum and the maximum will be the distance of any two critical points. Like the minimum distance will be the distance between two critical points is the minimum distance. Similarly, maximum distance is the maximum distance between two critical point at the farthest point. So we need to return that array. If it is, see, they're saying if there is no such point, like if there is no such critical points, we should return minus one for that case. So here are some example. We will look one by one each. If we see the constant, they are saying okay, number of node in the array can go from 2 10 to the power 5, and the value inside that node can go from 1 to 10 to the power 5. So if you see here, like they have strictly mentioned us like if any nodes having less than three, like if any linked list having node less than three, it will not work. Because like if I say, they are saying here, node should have a previous and the next point, and then we need to check whether it is a local minima or the local maxima. So let me draw that example with some example, like give an example. So if I say, let me take the first example. So let me draw the linked list. So let me take that once. Okay, so I have some linked list. Let's take like the few examples here. Okay, I might have this particular case. Now if I say how many element I have, so if I say I have what? In the first example, it is given me. Okay, the first example, if I say, let me draw it here. So if I say the first example 3 and 1, it cannot be considered as a local minimum or maximum because we need at least three nodes in it. Okay, so we need at least three nodes. That means here we need to return minus 1 and minus 1 as a minimum and the maximum distance. Okay, so this point, if I say if this is returning minus 1 and minus 1, this means minimum distance, and this particular means maximum distance between two critical points. Okay, so let me take the valid example. So here, if I say the valid example here is 5, 3, 1, 2, 5, and 1 and 2. Okay, so let me remove this one for now. Now, if you see here, I have what? I have this many elements over here. Now, if I say the question is asking me, okay, you need the node between any two. If you say the, if I say the start and the end, the farthest point cannot be concluded like included in the result set because it should have at least one element, or you can say one node before and one node after it. So this particular two element cannot be considered in my result set. Okay, so I will be starting my iteration over here, like I will be checking my conditions. If I say I have some boundary, my boundary will be this much. Okay, I will be doing some iteration over this particular boundary. Now, if I say, okay, if I'm checking each element, like if this is element, I'm checking whether this element is strictly greater than the previous and the next. That means I need to know my status of a previous and I need to know my status of a next element and its value. So that means I need to have something similar to three pointers. So let's say like, okay, there will be one pointer name as previous, we might have the current we are standing at, and we will be pointing to our next element. Okay, the next, you can say next node. So I might be tracking my three different nodes over here. So this is our next node. It means this is one node, and this is one node, and this is one node they are pointing to. So let me take a different color. Okay, so this particular is pointing to this particular is pointing to this, and this particular is pointing to this. Now each time I will be checking if this current pointer is strictly greater than or less than equals to the, like you can say, the neighbor node. So 3 is greater than 3 is less than 5, but it is not less than 1. Similarly, it's not greater than 5, and it is like, so if we are satisfying these two conditions, like if I say I have some condition like my current node value should be either strictly greater than my next value, or you can say strictly less than my next value, or it should be strictly, you can say we are checking for a minimum. So if I say, okay, my previous value should be larger than this, so I say, okay, previous value should be larger than my current value. So this is my current value. I need this value should be less than in the both case, or this one more condition. This is for local. This is for local. We are checking for minima. Okay, and same for local maxima. If I say for local maxima, I need a condition like, okay, I might have my previous value, it should be less than, okay, we are checking for local maxima. That means my previous value should be less than the current value, and the next value also should be less than my current value. That means I am I'm just getting this particular boundary condition, which is known as is critical. Okay, so I might be checking whether this particular current value, so is it current value is critical or not. So this is not a critical. Okay, so I will be shifting my this three pointers. So like I will be placing this, if I what I say like our pointer, like we say ptr equals to ptr dot next. That means I'm just pointing to the next window. You can say next node. Now again I will be checking. Okay, so let me make that small. Okay, 1 second. So this is our conditions. Fine. Now each time we are checking whether this particular this particular node is critical or not. If I say, okay, one is less than 3 and one is also less than 2, that means I got my first critical point. Either you can have the minima or the maxima. So that means I need to now note down my first, and you can say the recent. I'll say, okay, so let me say, okay, for this particular case this is a minima. Again I will be checking for this particular case, is this a minima or not. So it is less than, like you can say like it is greater than 1, but it is not greater than 5. That means it is not a minima or maxima. If I say for this one, 5 is greater than 2, 5 is greater than 1, that means it is a local maxima. So we got this one as our, like you can say, critical points. Similarly for this one, this is smaller than this is smaller than this. We got two minimum. So if I say, let me mark, like I got two minimum points. So this is one critical point, this is one critical point, which is local minimum. Similarly, I got one point which is local maximum. So here I got one local maxima. Here I got my local minima. Here also I got my local minima. But they are not asking me whether you have local minima or local maxima. They are asking me this should be this local minima and local maxima will be known as the critical point, and I need to have a distance. Okay, if I say they are asking me the minimum and the maximum distance between these critical points in the answer. So if I say we need to return one 2D array, or you can say one array with two elements which have a minimum distance and maximum distance. Okay, that means okay, I need to pick any 2 point and it should give me the minimum distance and the maximum distance. So if you say like if I take any two corresponding, you can say the two nearest point, it should give me the minimum value. And if I take the like you can say first and the last value, or you can say first and the last minimum, or you can say critical points, the farthest critical point should give me the maximum distance over here. That means I need to store my first occurrences as well as the most recent occurrences. So I might be tracking my, I can say first show, like when it got show first, and I'll say okay. Similarly, I will be mapping my last show, like when it got showed first. Okay, so if I say this should have some indexes, let's say like okay one, uh, here it is 1, 2, 3, 4, 5, 6, and 7. That means I cannot have the indexes directly, so I might be like using some increment pointers over here. So if I say here, if I got my first pointer, that means I need to store that as my first row of a critical point. So if I say okay, at particular third index, here if I say at third index, I got my first critical point for this one. Now if I shift my this window to the next critical point, so let me take this again. Okay, this also fine. So this is my first critical point. Again, I checked and 2 is not a critical point. So I'll again accept my window. And if I see here the current, if I say this current is 5 now and it is local maximum, that means I got my last maximum again. It is at index 5. Again, see, the first show will be marked as 1, like I need the first occurrences, so I can get the farthest distance between any two critical points. So I will be marking this at only once, and this will be updated as soon as get some another value. So again I'll shift this pointer. I'll say okay, go to the next pointer. Now if you see here, this current is pointing to 1, which is also a local minima, because 1 is smaller than 5, 1 is smaller than 2. Again I got one minimum point over here which is at index 6. So if you see here, every time when we are just changing our location, you can say the distance, or you can say the indexes, like at which particular position, what particular indexes I got the this critical point. So that time when I say okay, if I say the previous one was at 3 and at 5 I got the current one, that means the distance is 2 for now. Similarly, if I say the last one was at 5 and the current one I got at 6, the distance is 1 here. So if you see here, like if I say the minimum point, you can say the minimum boundary can be this much. Okay, so if I say this can be my minimum boundary, okay, this will give me the minimum value, the minimum distance over two nodes. So if I say this particular nodes, this two node will be giving me the minimum distance. Similarly, if I say for this particular two nodes, it will be giving me the maximum value, maximum distance. So I might be tracking like, see what I can do. Okay, as soon as I get this minimum distance, either I can store this in the array. So if I say this is 1 point, so I might have some array which will be storing this critical point. Okay, so at index 3 I got 1 point. If I say here at index 5 I got 1 point. Here at index 6 I got 1 point. Now again I can iterate over this array. So if I say okay, first I can get the maximum using the first and last. So if I say okay, if I like reduce my first and last, this will give me the maximum distance. So if I say if I need the maximum distance of a two critical point, I can take the first and the last value. Okay, so this will give me the index value. Okay, first got at index 3, another got at index 6. So if I say the distance is 3 over here, so maximum distance I got 3. Now if I say the minimum distance, so I can just keep like take any two nodes. Again I can like say what is the difference between them. So here it is 2, here it is 1. The minimum is 1. So I and an answer I can return 1 comma 3, which is the answer for here. Like minimum distance can be 1, maximum can be 3. So, like this particular case, like we are doing this in a time complexity of order of n. But if I store this particular result set, like the critical points in some array, it will also take order of n as the space complexity. But we will be reducing this by tracking that at, like we can say, in place. Like we will be tracking this first and last row at the in place of the result set. So let me show you with some example of a code. So I will be like using some three pointer approach. So let me say I will be having my previous and I will be having my current value. Okay, which will be pointing, like previous will be pointing to head and current will be pointing into head dot next. Similarly, I might have our next value. We can say next node. These are the nodes, so it will be pointing to the current dot next. So I'm just maintaining three windows. Okay, so if I say current at 3, previous at 5, and next is at 1. So I'm just pointing this window. Now I will be maintaining my what? Minimum distance. Okay, distance. Similarly, I will be maintaining my maximum distance. So if I say what can be my maximum distance, so if you see here in an answer, they are like expecting to return as -1, -1. So maximum distance I can have as -1. But what distance I can have for the minimum? So let's say like it can be for sure like if I starting at some position, let's say like it should be infinity. Any minimum distance lesser than the infinity will be our expected answer. So let's say like I will be getting at float infinity value over here. That means any distance coming less than this will be our answer set. Okay, I got this to distance. At last, I will be returning this distance. So I'll say okay, minimum, return our minimum distance. Similarly, I will be returning my maximum distance. Now, before this, we will be maintaining two more things like what is the first and the last row. So if I say okay, first, like when it was showed first, like what is the first critical point I got? So I'll say okay, first row I got at let's say at index 0, 0 I got both like first say I'm saying like I didn't got anything, so I'll say it is 0, 0. So I'll say okay, first and last both are at 0, 0. Like I don't know which index, so let's say like okay at index 0 it is as the first row. Similarly, I will be starting some position like at what particular position I'm currently at. So let's say like I will be starting my index from 1. Okay, so this should be our some like variables we will be using. Now I will be shifting my this window. Now if you see here, like if I tell you one more thing, when the question told us like we can have only this much window in our frame, like we cannot include the first and the last because we need at least one element in the previous and one element at the last. So that means I need to terminate this particular like shifting of three pointers like whenever the next pointer reaches to the last value. That means I will be checking okay if this last become null whenever I shift this pointer again, like if I say this particular this three window, if I shift this one more, that means current will be reaches to next sorry, the next will be reaches to null and current will come to the last window, the last node. That means I need to terminate this point. So I will be like iterating over the next node you can say. So I have three nodes, the current first and you can say previous, current and next. So I will be iterating over the next node here. Each time I will be doing what? I will be making my previous equals to what? Current. Similarly, I will be making my current equals to what? Current will be becoming next. And similarly, our next will be going to, if I say the next window, next node will be going to what? Next dot next. So in Python, I can do this all in place. So I'm just written in this all thing at once. Similarly, each time I will be incrementing my position index. Okay. So let's say like it is not a position. Let's say this as a index. Okay, fine. Now, whenever if I say, let me create one more thing like instead of writing, I'll say, okay, I define one function is critical. Critical. Okay, is critical. I will be passing our previous, current, and next node over here. Now, if I say I will be returning over from here, like if I have two conditions, if it is a local minima, so if I say if it is a local minima, okay, local minima means if I say like if the previous value is greater than the current value, similarly it is also like the current value is also less than the next value. So I have three nodes. Okay, I have my previous node, current node, and next node. If the current value is less than both of these neighbor node, like the previous and next, that means it is a local minima. Or similarly, I have one more condition. Like if it is strictly greater than the previous and the next node, that means it is a local maxima. So the next one is what? So let's write over here like this is a local maxima. Okay. Again here it was the local minima. Okay. Let's remove from here. So this will be returning me if any of the conditions satisfy from this window, it will return me true, else it will return me false. So each time I will be checking what if the current pointer is at like if the current pointer is the local minima or not, or the critical point or not. So I'll say if is you can say is critical, and I will be passing my previous, current, and next. Okay, so I have passed these three nodes. If this give me this set gets satisfied, like if here if you see in this particular case, if current is at 3, it's not valid. With current at 1, that means it is a local minima. It will return me true from here. So whenever it return me true, I'll check if I already have a value of a first so. If it is the case, I need to update only my last so, or you can say minimum and the maximum point. But let's say if it is not a case, that means at this time I will be initializing my first so for the very first time. Okay, that means I will be updating my current index value. That means I got this first so at this particular index. Now each time, let's say like if it is not a case, like if we already have my first so, that time I will be like checking, I will be storing our maximum distance. If I say maximum distance will be what? So it will be like current index position minus whatever is the first so. Okay, so this is the farthest, like if I say this first and the last point. So this will be our first point, it will be last point for each step. Now, if I say similarly, I will be having my minimum distance, which will be minimum of what? So it will be minimum of minimum distance. Okay. Now I will be checking what? The current index value and minus the last shown we have got, like the what is the last show we have. So I got at any particular index. So this will be giving me the minimum distance. Each time, whenever I found a critical point, each time I will be updating my what? Last show from here. So last show will be becoming what? It will be becoming my current index. Okay. And this is shifting my current window, and this is incrementing my current pointer. And here I am checking whether it is a critical point or not. Now, one more thing, like what if we have only two node over here, or what if like we didn't got any nodes which is critical in this particular point? Like suppose we have initialized this our minimum distance to infinity. What if it remains same? Like let me compile this code. You will see like they will be saying okay you cannot return something. 1 second, we have missed something. So they are saying, okay, here I give an underscore. Let's compile again. So if you see, okay, here they are saying you cannot expect infinity. That means, for some cases, that means if I say for this particular case, it should expect it -1, but we have defined that as infinity. So if I say, okay, if at last this particular case, if I say, okay, minimum distance, it still remains what? Float infinity. That means this time I need to change this minimum distance to what? Distance to -1. That means I didn't got any point. Let's say it's to be -1, like here we did for the maximum. Similarly, this should be our answer. So let me compile this code again and let's see whether it is running fine or not. So I can say it is also, so it is still giving me minus infinity is not expected. So we are defining this as a -1. Okay, so what's wrong here? Let me compile this again. So it is giving me what return type is infinity. But we are updating this. Okay, we are giving the double equal. So it is just checking again the condition. So I need to give single equals to which is assigning the -1. So it is accepted. Let me submit this code. So let's see whether it is fine or not. So I can see this code runs successful and a little bit optimized. Like we have done this in a linear time complexity of order of n, whatever nodes are present, and we have done in a linear space, like constant space. We didn't use any array or such to store the local points. So yeah, that's all for today's. Thanks for watching.